today to talk to you about electric current. And I want to emphasize the fact that we're kind of on another unit, because this is different than electrostatics. Right now we have charge that is moving through wires, right? And we'll talk about how to build circuits, and we'll build circuits. We have flowing charge, constantly in motion. And the charges that are moving are typically electrons, right? But we often define current as being positive, and it's a strange thing. So let's say the positive current is moving to the right. If the positive current is moving to the right, it doesn't really mean that positive charges are moving to the right. It means that electrons are moving left. But if they do, they leave gaps. And the gaps they leave is very similar to as if positive charges were actually moving to the right. So we'll talk about positive current being the flow of positive charge. It's the same, it's equivalent to electrons going in the opposite direction. Okay, so current is the term that we use to talk about how much charge passes a particular point in time every second. It's the rate at which charge passes a point. So current, which goes by the letter I, is defined as like the number of coulombs of charge that pass a point every second. So you could take this wire, for example, and you could put a detector there and say, hey, what is the charge? And the charge is how many coulombs, and it's written as delta Q, meaning the change in charge, right? You could just think of it in terms of Q if you want, divided by the time. So if you had 3 coulombs over, I don't know, 6 seconds, 3 coulombs over 6 seconds that pass through that point, then your total charge is 1/2 amp. And current is measured in units of amps, amperes. And that is a scalar quantity. Now, we know that the charge that passes is going to also depend on, well, the number of particles that pass in the charge per particle. So if you remember, the total charge that passes can be defined also as the number of charges times the charge per particle. Excuse me. So the number of charges times the charge per particle divided by time is also the current. So if instead of this, let's say that we had, I don't know, 1 million electrons. Pass a point in 1 second. Well, we'll say 2 seconds, why not? 1 million would be 1 times 10 to the 6th. That's your number. The charge of an electron is 1.6 times 10 to the negative 19th coulombs. The amount of time we said is 2 seconds. We're going to see that this is a pretty small number right here, but you get 1e6 times 1.6 by 2 is going to be 8 times 10 to the negative 14th amperes. So a pretty small number right there, which tells you that even if you have 1 million electrons, that's actually quite a small number of electrons. So when we talk about charge passing a point and the number of coulombs, coulomb is actually a pretty big quantity. And 1 amp is quite a lot of energy and charge passing through a single point. Your house might be equipped to handle like 100 to 200 amps. Your average device might draw, like, I don't know, a toaster might draw 8 amps. So it's drawing quite a lot of charge, but there are many devices that we have that draw far less charge than these. There's a couple other terms that we often use. we're going to see more as we go on. We've talked about current a little bit. We talked about voltage a little bit. So we often use voltage or potential difference when talking about circuits, and we often talk about resistance, which is a measure of how much a material resists the flow of electricity. So the more of an insulator it is, the more it will resist the flow. The better a conductor it is, the more that it will allow the flow, so the smaller its resistance will be. And I mentioned this because we're going to use a few different tools to measure stuff. We're going to use ammeters, which goes by A with a circle if you see a circuit symbol. We're going to use voltmeters, which goes by V. And they do also sometimes have resistance meters that we'll use too. An ammeter measures amps. A voltmeter measures volts. If you measure resistance, that's in terms of ohms. I'm going to talk about that in a future one. Just so you're familiar when you use the equipment. There's one other thing I want to mention too, is we before talked about conservation of charge. And so we still have conservation of charge when we're dealing with electric current. And we just think of it differently. So imagine you have an ammeter here, and that ammeter measures a certain amount of current. Let's say that it's 10 amps that goes through this particular point right there, and it comes to a junction. So when you come to a junction, the current in has got to equal the current out, meaning the number of coulombs total per second that comes in has got to equal the amount out. That would be your junction right there. So two separate ammeters, and there's different reasons why current might flow in different amounts. But we know that if you measure 5 coulombs through the top, and it's going out this way, well, if you've got 10 coming in, you got to have 10 coming out, so you got to have another 5 amps at the bottom as well. If instead you had like 3 amps at the top, well, you've got to have a total out that's equal to your total in. So that means you've got to have 7 amps at the bottom. And this is called Kirchhoff's law, and you'll see it in various forms. Just make sure you pay attention to the arrows. It can get a little bit complicated, and you can split into different paths. You can split into 3 paths here, so you could say 10 amps. And then you could have 2 amps. You could have 4 amps. What's coming through here? Well, it's all coming in, right? So let's like do 10 in, 4 out that way, 2 out that way, so you've got to have another 4 to add up to your total of 10. It could be coming in a different way. Let's say if instead of going out, you had 2 things coming in here, boom, boom. Now you've got 12 in, depending on which way the current's flowing, just pay attention to the arrows. 10 plus 2 coming into this junction right here means you got to have 12 out. So if you've got 4 out that way, you got to have 8 amps out that way. Kirchhoff's law, conservation of charge. I think that does it about now. I'm going to get to more on resistance and voltage and the relationship between them in the future video. Thank you very much for watching.